Welcome to the deep dive. Today, we're jumping into something truly fascinating. Wormholes.
Ah, yes, the classic sci-fi trope, but with real physics behind it.
Exactly, but not just as shortcuts across space, right? We're asking, could they be doorways, like actual doorways to whole other universes?
That's the really big question. Could these theoretical tunnels through space-time actually, exist?
Yeah.
And could we use them?
So that's what this deep dive is all about. We'll explore the theory, the science, and honestly, the kind of mind-bending consequences if these things are real, connecting potentially to parallel worlds. For you listening, strap in.
It definitely takes us to the edge of physics. I mean, wormholes, they really come out of Einstein's work, general relativity.
Right, Einstein and Rosen back in 1935.
That's the one. They found these solutions in the equations, these sort of mathematical bridges. Einstein-Rosen bridges, they called them. The math suggested you could potentially link up really distant spots.
In our universe.
Or maybe, just maybe, link to a completely different universe altogether.
Okay, let's make that concrete. The whole space-time fabric idea.
Right.
It's not just 3D space, it's space and time woven together. And a wormhole. It's like, what, folding it?
Exactly. Imagine you take a sheet of paper.
Hmm.
That's your space-time. You want it kept from one side to the other, the long way around. But if you fold the paper over, the 2 points are suddenly right next to each other.
Okay, yeah.
Then you just punch a hole straight through.
Yeah.
That's your wormhole. A tunnel.
A shortcut. So for you listening, it's like finding a cheat code for cosmic travel, bypassing all those light years.
That's the appeal, absolutely. The paper analogy is great for the concept, but the physics to actually make it work, that's the tricky part. A really big hurdle is stability.
Meaning they just collapse.
Pretty much instantly, according to the standard models. Way too fast for anything, even light, to get through. They'd pinch off.
Okay, so theoretical tunnels that slam shut. How do we prop them open then? What's the theory?
Well, this is where it gets really, really weird. The leading idea involves something called exotic matter.
Exotic matter. Sounds exotic.
It is. See, regular matter, the stuff all around us, has positive energy density. It pulls things together with gravity.
Right. Standard of gravity.
Exotic matter, theoretically, would have negative energy density, would push space-time apart. Repulsive gravity, kind of.
Negative energy. Pushing things away. How does that even work? Where would you find that?
Well, we haven't exactly found piles of it lying around.
Yeah.
It's more something that pops out of some interpretations of quantum field theory. But the idea is this repulsive force could act like a scaffold. It could counteract gravity's tendency to crush the wormhole closed.
Ah, so pushes outward, keeping the tunnel open.
Precisely.
Ah.
Kip Thorne and some colleagues wrote a key paper on this back in 1988. They explored if you could stabilize a wormhole with this stuff. And if you could, well, then it becomes potentially traversable.
Traversable for, like, a spaceship. Or maybe just signals.
That's the question.
Yeah.
But if it's stable, suddenly the doors open, maybe literally, to thinking about passage, even perhaps passage between universes.
Okay, my brain is officially starting to bend now. Because it's not just about distance, is it? You mentioned space-time, so time travel.
That's the other major implication, yeah.
Yeah.
Because wormholes link points in space-time, not just space. So they could potentially be shortcuts through time, too.
How would that work, linking two different times?
Well, imagine you have a wormhole with two mouths, two openings. Let's say you could somehow take one mouth on a trip.
A trip where?
A very fast trip, close to the speed of light, relativistic speeds. Then you bring it back. Einstein's relativity tells us that time passes slower for things moving really fast. So the traveling wormhole mouth would have aged less than the stationary one.
So there'd be a time difference between the two ends.
Exactly, a time gap. So theoretically, you could enter the younger mouth, the one that took the trip, and exit the older mouth in the past relative to when you entered.
Whoa. Okay, so stepping into a wormhole could actually send me backward in time.
Theoretically, yes.
But wait, that leads to all those paradoxes, right? The grandfather paradox. What if I stop my own birth?
Precisely. That's a huge conceptual problem.
Yeah.
It's led many physicists, like Stephen Hawking, to suggest there might be rules against it.
Rules. Like laws of physics preventing time travel.
Sort of. Hawking called it the chronology protection conjecture. The idea that the universe somehow prevents these causal loops from forming. Maybe wormholes with time differences are just impossible to create or stabilize.
A cosmic safety net?
Perhaps.
Yeah.
But it's still debated. Some ideas in quantum gravity, the theory trying to unite gravity and quantum mechanics, might allow for weirdness like self-consistent loops or maybe branching timelines.
Branching timelines. Okay, now we're really getting out there. That sounds like the multiverse.
It connects directly to it.
Yeah.
especially the many worlds interpretation of quantum mechanics.
That's the idea from Hugh Everett back in the 50s.
That's him. He proposed that every time a quantum event has multiple possible outcomes, the universe doesn't just pick one. It splits.
Splits into parallel universes.
Essentially, yes. A separate universe branches off for each possible outcome. An unimaginably vast number of parallel realities.
Okay, so if many worlds is right, and there are all these other universes coexisting, could a wormhole be the connection, a bridge between them?
That's the speculative leap, but it fits conceptually.
Mm-hmm.
If wormholes can link different points in space-time, maybe they can link different spacetimes, different branches of the multiverse.
So for you listening, imagine choosing left instead of right this morning. In another universe, maybe you went right. Could a wormhole take you to that reality?
It's a staggering thought. You could potentially access realities where physics is slightly different or maybe wildly different. Universes where history took another turn.
Like a universe where Rome never fell, or one where Earth, I don't know, didn't even form.
The possibilities are literally infinite if the many worlds view holes and wormholes can connect them. You might step through into something utterly alien or something eerily familiar, but changed in crucial ways.
It's incredible to think about. But, okay, let's pull back from the theory for a second. Have we actually seen anything that looks like a wormhole? Anywhere?
No, nothing direct, no photograph, no confirmed signal. They remain purely theoretical constructs for now.
So where might we even look, if they do exist naturally?
Well, the theories suggest they'd need extreme conditions,
Mm-hmm.
very strong gravity. So maybe inside or near black holes, that's one place people speculate.
Mm.
Or perhaps connected to hypothetical objects called cosmic strings, leftover defects from the early universe. But these are also theoretical.
So no smoking gun yet. What about trying to make something like one? I remember hearing about that quantum computer simulation.
Ah, yes, the work from Princeton and others in, 2022, published, I think, that caused a stir.
They made a wormhole.
Not a physical one you could walk through. It's important to be clear there. What they did was use a quantum processor to simulate a system that behaved mathematically like a traversable wormhole. It involved quantum teleportation protocols and showed properties related to how information could, in theory, pass through such a structure.
So it was more about the underlying physics, linking quantum entanglement and space-time geometry.
Exactly. It was a simulation showing that the equations describing entanglement on quantum bits could look remarkably similar to the equations describing a wormhole connecting two black holes in certain theories of gravity. It's a clue about the deep connections, not a construction project.
Still pretty amazing that we can even simulate that kind of thing. Are astronomers actively scanning the skies for real ones, though? Any projects looking for anomalies?
Oh, absolutely. Instruments like NASA's NICER telescope, which studies neutron stars with incredible precision, are looking at regions of extreme gravity. Scientists analyze the data for any weird gravitational effects, any unexpected light bending or radiation patterns that don't fit standard models, anything that might hint at something exotic, like a wormhole mouth.
It's a long shot, I guess.
A very long shot. But we're looking. Science is definitely moving from pure imagination towards, building the mathematical framework and even probing the quantum connections.
Okay, let's play the what-if game again. Suppose we find one, or figure out how to make a stable one. What are the downsides, the dangers we'd need to worry about?
Oh, the dangers are potentially immense. We already talked about the time travel paradoxes. Messing with causality could be, catastrophic, unraveling cause and effect.
Yeah, that seems bad.
Then there's the interuniversal connection aspect. What if you connect to a universe with fundamentally different physical laws? Could matter or energy spill through in a way that destabilizes our universe? Or theirs?
A kind of cosmic contamination.
Potentially.
Yeah.
Or just a massive, uncontrolled energy release. We simply don't know what happens when different sets of physical laws interact directly.
And then there are the more human problems?
Right. If accessing other universes becomes possible, who controls it? What stops one group from trying to exploit the resources of another reality?
A multiversal colonization. Or even war. That sounds terrifyingly plausible. Depressingly so.
It opens up geopolitical or maybe multiversal political risks on a scale we can barely comprehend. And the ethics. If there's life, even conscious life, in these other universes, what are our responsibilities? Do we have the right to just barge in?
It's a minefield. Suddenly, Hawking's idea, the chronology protection conjecture, sounds quite comforting again. Maybe nature does stop us from opening these doors.
It's a possibility, a natural safeguard against the worst kinds of paradoxes or interuniversal chaos. But again, our understanding of quantum gravity is incomplete. Maybe some forms of interaction, some types of traversable connections are allowed under the ultimate laws of physics. Maybe time loops resolve themselves, or timelines just branch without contradiction. We just don't know yet.
So opening a wormhole, if possible, is like opening Pandora's box. You might get incredible wonders or
Something
else entirely.
exactly. It could unlock everything, including possibilities we really, really wouldn't want.
Which brings us back to the start. For everyone listening, wormholes. Are they pure fiction or maybe just science waiting to happen?
It's the core question.
And if you were faced with that tunnel, that shimmering gateway to somewhere else, would you step through? Would you take that chance?
What would you hope to find?
And imagine meeting another version of you, someone who made different choices. Would they still feel like you? Or like a stranger? It really makes you think about identity.
Deep questions. We definitely encourage people to mull these over. Maybe drop your thoughts in the comments carefully in case your alternate self replies.
Good point. But really, the main takeaway here isn't just about whether we'll ever build stargates.
No, it's more fundamental.
It's that even thinking about these possibilities, pushing the boundaries of theoretical physics, expands how we see reality itself. It forces us to grapple with the sheer strangeness and scale of the cosmos.
Absolutely. The quest to understand these extreme ideas stretches our minds, even if the physical objects remain elusive.
So, keep asking questions, keep wondering about space-time.
And maybe, just maybe, be a little cautious around any weird-looking tunnels.
Couldn't have said it better myself. Until our next deep dive, thanks for joining us.